Okay, I have to make a new video here, so I don't have a class with me. So I'm just talking to myself. And I'm making a new video of this lesson because I've changed slightly the way in which I teach how to do these calculations. Oop, let's back up. Okay, so this lesson is on something called the mole. And no, I don't mean a furry creature that doesn't see very well, that burrows through the ground. A mole is a special number to chemists, and it's a very big number. And the reason chemists need a very special big number is because atoms are so small. All right, atoms are very tiny things. In our last lesson, we learned about the formula mass. So if I had something like, say, water, and you don't have to write this first stuff down, I'm just putting some examples. If I had something like water, 16.0, 1.0 times 2, 18.0. Remember, that's how we get our formula mass. The unit that I told you to use for that is something called U, atomic mass units. And that's how heavy one molecule of water is. Now, a molecule of water is a very small thing. And therefore, that 18U is very, very tiny. So when we want to do chemistry, sometimes we have to weigh out or measure some volumes of various substances. And we don't measure them in U because it's way too tiny. We'll put them on a scale and we'll measure it in grams. Because we can measure grams. U's, we can't really measure. They're too small. In actual fact, the mass of 1 U is 1.66 times 10 to the negative 24 grams. That is a very, very small number of grams. So what do we do as chemists? Well, just like when we have small things that we want to purchase, like, say, pencils, we put them into large groups. Like dozens. You could buy a box that is a dozen pencils. You could even buy a larger box that has a dozen boxes in it. If I had a dozen boxes that each carried a dozen, that would be 144 pencils. All right? I think that's called a gross. That's an interesting term. I think that's what the term is. So we group things. All right? So we need a special group that's useful to chemists. And this special group is called the mole, all right? And so just like we have 1 dozen, all right, equals 12 things, let's go with eggs. In terms of chemicals, we put things into what are called moles. And it turns out that 1 mole, all right, is equal to 6.02 times 10 to the 23 tiny little things. Now, those tiny little things could be atoms. They could be atoms of hydrogen, or they could be molecules of water. Remember, in the last lesson, we talked about those tiny things of chemistry, and we grouped them together into what we would call entities, all right? So 1 mole would have 6.02 times 10 to the 23 entities. Could be atoms. Could be molecules of water, could be ions or formula units. All right. So let's officially write down some of this information, and then I'll show you how we use this number. So again, I'm just going to read through this. You could pause the video because I don't have any students here to wait to write. So I'm just going to talk about it, and you can write it down at your speed. 1 mole of any substance contains Avogadro's number of entities. Now that number that I just stated is what we would call Avogadro's number. All right? Whoops, I didn't want to do that. Get out of there. Is what we would call Avogadro's number. All right? So Avogadro's number is 6.02 times 10 to the 23. Oh, now I've messed up my... Hold on 1 second. See if I can get it back. 6.02 times 10 to the 23 entities. 23 things. So we give this special number a special name, Avogadro's number, and we give it the symbol N subscript capital A. Avogadro was a an Italian physicist who did work on gases and the way they behave. And ultimately, the work that Avogadro did allowed other chemists to calculate this special number. And it is a very special number, and we'll learn why it's special in the next lesson. Okay, so as I said and wrote down just moments ago, 1 mole is 6.02 times 10 to the 23 entities of an object. So this allows us to do calculations to figure out how many moles of a substance we have if we know how many entities we have. We can create a formula, all right? Or if we know how many moles we have, we can then determine how many entities there are. So it allows us to go from tiny things to these groups of things, all right? So it allows us to go from the tiny entities to these groups that we call moles, all right? Now, the word is M-O-L-E, but when we write it down simply as M-O-L, like a short form. It's not much of a short form. We only lose the letter E, but it's the same as if we were talking about meters. We don't write it out as meters. We write it out as just M. You'll notice in meter we get rid of a lot more letters than in the word mole, but that's kind of the way it works. Okay, so 1 mole is 6.02 times 10 to the 23 entities. So let's learn how to make calculations with this. Well, we're going to create a formula eventually, but first let's talk about something that we already know. Let's say, and you can write this down, let's say that we define 1 dozen as 12 things. Let's say eggs, all right? And I'm going to cut this in half because on the other side here, I'm going to deal with moles. Well, we can understand and think about dozens and eggs because they're larger, eggs are larger, and there's a smaller number of them, but the logic still is the same. So let's say that I had 2.7 dozen, and I want to figure out how many eggs I have. Now, some of you right away are able to kind of see and think the logic. If 1 dozen is 12 eggs, then 2.7 dozen would be 2.7 times 12. And that is exactly correct, times 12. Times 12 eggs, and technically it's eggs per dozen, all right? So in the end, we multiply the two numbers in order to get it. And just because we're doing some math and nobody's here, 2.7 times 12 equals 32, what did I just get? 32.4 eggs? How do I get 32.4 eggs? But I must have 32.4 eggs. That's fun, and that's because I've got a 0.7. We won't worry about the logic behind it. You probably won't want that 0.4 of an egg. It might be a little messy. Anyway, you can see that we multiplied the two, all right? Now let's think about the mole. 1 mole is equal to 6.02 times 10 to the 23 entities, little tiny things. So the logic is exactly the same. If I had 2.7 moles of something, how many entities would there be? Well, each mole has 6.02 times 10 to the 23, so in the end, I'm going to multiply just like I multiplied moments ago for the dozens. And it's technically entities per mole. That's how many entities there are in each mole. So again, I just need to multiply. So if I want to get the number of entities, I have to multiply the moles by Avogadro's number. And I'm going to do that right now. 2.7 times. Now, we need to learn a little bit about our calculators. I'm now going to put in that number in scientific notation. And I'm going to write 6.02, and then I'm going to press the EXP button, and then 23, and then press equals. And I get 1.625, so let's go with 1.63, 3 significant digits, times 10 to the 24, and that is then going to be entities, all right? Okay, So, a couple of things here. How do we get the number that we want to get? Well, let's think about what we did. I'm going to take the number of moles, which I'm going to call N, and I had to multiply it by that big number called Avogadro's number, Na. And what did that get me? That got me the number of entities, the number of tiny little things. And we're going to call that capital N, right? And I'm going to explain why we're going to call that capital N in a moment. Okay. Now, a second ago, I was talking about how to put numbers in your calculator and how you deal with that number. When I go on to more examples, I will talk more and explain in more details what you have to do with your calculator to get that. But what we've just done is we've created an equation where we can calculate the number of entities if we know the number of moles. So let's write down some of these equations and see if we can use it to calculate it. So calculating entities in moles. I have just stated the equation is N equals small n times Na. So let's define those values. Na we've already seen. It's 6.02 times 10 to the 23 entities per mole. That is called Avogadro's number. That's actually on our equation sheet, not on the periodic table itself, but on the equation sheet, which is what I would call the back of the periodic table. And that number is always there. So if you forget the number, you can always check it. Lowercase n, in all of our chemical equations, lowercase n stands for the number of moles. The number of moles, all right? And so its unit is moles. So we're looking for a number in our question that ends in moles. And capital N always determines the number of entities, the number of those tiny things that we talk about in chemistry. And they tend to be really big numbers. Because atoms and molecules are so small, there are lots of entities, billions and billions and billions of them. So the number of entities tends to be a big number, which is why we use a big N. All right? So the big N stands for entities because that tends to be a big number. When we put those entities into moles, the moles number tends to be a small number because we've put them in these big chunks, these big piles called moles, and therefore we use a small n. All right, so that's why we use the letters that we do in this equation. And Na is a constant number, it never changes. It's also a big number, so we use a big N, and the subscript A tells us it's Avogadro's number, which is 6.02 times 10 to the 23. So, what if I wanted to calculate the moles? Well, then I'm going to rearrange this equation. N equals N times Na. And if I want to get little n by itself, I am going to divide Na off from both sides. That's the way we do our math, right? We divide off what we want to move because this is a multiplication. And that's going to leave capital N divided by Na. So a second version of this equation is N equals capital N over Na. All right. Now, for those of you who don't like doing the math, and I think there's quite a few of us maybe here that don't like doing the math. For those of you that don't like doing the math and rearranging, you may have heard or saw teachers put equations into triangles so that you can rearrange things easily. The way this system works is if you have a fraction like this, the letter that's at the top of the fraction will go at the top of the triangle, capital N. and the other letters will go at the bottom. And A and N. All right? So how does this triangle work? Well, I can't show you because I don't really have access to my hand, or I could use the cursor. I could say, all right, if I want to find the equation for entities, I cover up the N, and you can see there that all that is left is little n times NA. All right? So you can see in this equation, N is equal to little n times NA. Just like covering up this N is equal to little n times NA. Now, if I want an equation to solve for little n, I cover it up, and you will notice that it is now capital N over NA, capital N over NA, capital N over NA. So that triangle right there will tell us how to rearrange the equation. All right. Let's do some questions. Okay. Next slide. See if I can find my cursor here. Okay, so let's do some examples. Find the number of entities in 1.7 moles of CO2. So I'm looking for entities. Remember my triangle, capital N, little n, NA. And remember, entities are right there, and moles are right there, and that is our Avogadro's number, 6.02 times 10 to the 23. So I want to find the number of entities. N equals N times NA. 1.7 is the number of moles times 6.02 times 10 to the 23. Now, let's talk a little bit about how that's going to work on your calculator. Actually, I might be able to show you the way that's going to work on your calculator. I forgot I had this. This is going to make my video a little longer, but let's see. Okay, awesome. It's going to work if I can get a hold of this thing. Oh, take a look at that. There I got a calculator. Looks great. So let's see what this looks like. 1.7, beautiful, times. Now I need to put in this scientific notation, 6.02. Scientific notation, we do not press times and we do not press 10. We press a button that says EE or EXP, all right? EE or EXP. So depending on your calculator, this function times 10, you press EXP if you've got a Sharp, or if you've got maybe, I think, a Casio, or you press EE if you have a Texas Instruments. Okay, so notice I'm not going to press times. I'm not going to do that. I'm not even going to use this 10 to the X. There's a little 10 to the X up here. It looks like this, but I'm not using that. That's for something else. I press EXP, and it shows a little E right there. That's just the way the calculator expresses it. That E is the times 10 to the. Now I put 23, and now I've got the calculation in the way I want it to look. I press equals 1.0234E, which again is times 10, and then 24. Now let's talk a little bit about significant digits. This has only 2 significant digits. It's not very accurately measured. This has 3 significant digits. It's measured more accurately than this. So when we write our answer down, we will only keep 2 significant digits. 1.0, I'm going to round this down because it's a 2 times 10 to the 24. So this gets written as I want it in green. Just keep things consistent. 1.0 times 10 to the 24. All right. So I've just shown you how to run your calculator. Let's leave that off to the side. We're going to need a calculator in a moment. What are the units of this thing? Well, carbon dioxide are molecules. So they're entities or molecules of CO2. All right. When you do a calculation, please tell me what type of entities there are. You could have wrote molecules, but entities of CO2 is just fine. All right? The CO2 tells me what we're dealing with. Okay. Let us do the next one. Come on. There it is. So, moles of sodium chloride. I want to find the entities, so I'm going to start with the same equation. N equals little n times Avogadro's number. 5.67 times 6.02 times 10 to the 24. Again, I'm going to bring the calculator up just as a reminder on how to do it. So let's clear. 5.67, 5.67 times. Now the scientific notation, 6.02 exp. Oh, sorry, that's not a 24. That's supposed to be a 23. 23. There it is. I fixed it. 23 equals 3 significant digits. 3 significant digits. 3.41 stays down because that's a 3 times 10 to the 24. 3.41 times 10 to the 24 entities of NaCl. And these entities are formula units, but that's okay. We will just leave them as entities. All right. Let's move on. Let's do the calculation the other way. Find the number of moles in. Again, my triangle, entities, moles, Avogadro's number. This time I want to find the number of moles. So I cover up the N. That means moles is equal to entities divided by Avogadro's number. That makes good sense. We're doing the opposite calculation. Okay, let's keep going. 4.0 times 10 to the 15 entities of water. Notice it says molecules. Remember, molecules are entities. Divided by Avogadro's number. 6.02 times 10 to the 23 entities per mole. All right, let's do that. Getting my calculator. Clear. 4.0 exp 15 divided by 6.02 exp 23 equals. Now notice here, this runs me right off the edge of the calculator. That means I need a little more information here. I don't know what that extra digit is, because I need to round to 2 digits. So I need to change this into scientific notation. Now your calculators are going to be all a little different. A sharp calculator, I will check the mode. And I'll press mode again. Wait a minute. Stat drill table, mode, normal. No, this one isn't going to be under mode. Let's go home. Let's go setup. There it is. FSE. So FSE under setup, click 1. Will tell me how to change this to scientific notation. Each calculator is different. Come and talk to me if you can't get your calculator into scientific notation. F stands for fixed, scientific, and engineering notation. I want scientific notation. How many significant digits do I want? In this case, I only want 2, but I'm going to put 5. I'm going to let my own figure it out. Now notice it forgot what my calculation was. Now it's in scientific notation. It's got an E on it. I'm going to recalculate. 4.0 exp 15 divided by 6 point, oops, forgot the point. Can I go back? You bet I can. 0.02 exp 23 equals, syntax error. What did I do? Clear. Start again. 4.0 exp 15 divided by 6.02 exp 23 equals 6.6 times 10 to the minus 9. In the standard notation, we couldn't see what that number was. We couldn't see the 6. That's why we had to change it. So you got to be careful. When you see a bunch of zeros and a number at the end, you need to change your calculator into scientific notation. 6.6 times 10 to the minus 9. Now, after all of that, what did we calculate? Well, we calculated little n. That's moles. So we calculated moles of water, I believe. Moles of water. Yeah, there's the question there. Moles of H2O. That's a pretty tiny number of moles. But take a look at the number that we started with. Times 10 to the 15. That's a lot smaller than 10 to the 23. So it makes good sense that we don't have quite a mole. We've got much less than a mole. Let's do another example. How many times do I have to click it? There it is. 5.67 times 10 to the 26 ions of potassium. Same calculation that we just did. We're looking for moles. N equals entities over Avogadro's number. 5.67 times 10 to the 26 entities, ions of potassium, divided by 6.02 times 10 to the 23 entities per mole. That's how many there are in each mole. Let's get our calculator and do it. Notice this time, 10 to the 26 is a lot bigger than 10 to the 23, so we won't have this tiny number of moles this time. Calculator, drag her in, clear. 5.67 exp 26 divided by 6.02 exp 23 equals. It's now a fraction. Oh, what did I do to my calculator? Mode, go to normal, for crying out loud. Oh, let's try that again. 5.67 exp 26 divided by 6.02 exp 23 equals. Really? A fraction. That's what you're going to do for me. How do I get it out of here? Is it the BS button? This is a bunch of BS is what's going on here. No, it's not the BS button. I hate it. Why do these things do this? Equals 941 and 37/43 setup. I'm going to go FSE 1. I'm going to go normal 2, 4. Still didn't do anything. It's not in scientific notation. What a silly thing that is. All right. Home. I'm going to pause my video and see if I can solve the problem. Just 1 second. Okay, I think I solved it. It's not a nice fix. This button down here, this change button, allows you to switch it. So if I push it, it does it like in a really bad fraction. If I push it again, it gets us a decimal. That's what we want. 941.9, 3 significant digits, 941, that rounds to a 2. So technically speaking, to 3 significant digits, that's 942 moles. Moles of what? Moles of potassium. Potassium ions, so K plus, all right? Okay, so you can see there that when I want to find moles, I'm going to divide Avogadro's number. All right, there's one more type of calculation I want to do here to finish this off, and then my lesson is over. So the chemical formula sometimes comes into play with a question like this. Find the number of chloride ions in 2.34 moles of aluminum chloride. Now this is a different question. Ions are entities. They're the tiny little things. But notice I have moles of this ionic compound or formula unit. So let's talk about how to get the chloride ions out of that. So to begin with, we are looking for ions. We're looking for entities. We're looking for the little tiny things. And we're starting with moles, which means we've got the small n. Let's get our triangle. Entities, moles, Avogadro's number. And we want to find the number of ions. And ions are entities. So my equation is N is equal to the moles times Avogadro's number. So let's put that in. 2.34 times 6.02 times 10 to the 23 entities equals. Let's calculate that up. Again, I got to sit down at my computer and I got to grab my calculator. I'm going to clear it out. 2.34 times 6.02 exp 23 equals 1.408. Again, I have three significant digits, so I'm going to keep 1.4, and that 8 is going to make it 1.41 times 10 to the 24. Now, I have to be very careful. This is entities of aluminum chloride. And so I need the formula for aluminum chloride. And when I cross over the charge of 3 from aluminum and the charge of -1 from chloride, I get that formula. So notice the question asks that we want to find the chloride ion. In other words, I just want to find the Cl's. Notice there are 3 chloride ions in each aluminum chloride. Realistically speaking, it simply means that I have to calculate, or I have to multiply that final answer by 3, because there are 3 chlorides in each aluminum chloride. This is the way I like to set up the question. 1.41 times 10 to the 24 entities of aluminum chloride. What I do now at this point, and you don't have to write it like this, I really just have to multiply it by 3. Sorry, I need that 3 right there. So I really just need to multiply it by 3 because there are 3 chlorides in each aluminum chloride. And so I like to write this like a fraction. 3 chlorides per 1 aluminum chloride. There's 3 chlorides per 1 aluminum chloride. Notice if I'm canceling things, like I can mathematically speaking, I have an aluminum chloride here and an aluminum chloride there. And so when I do this calculation, I'm simply going to multiply the 1.41 times 10 to the 24 by 3, and I've determined the number of chlorides. So sometimes we have to do that. Now notice I've got an answer that's already there. There's my number. I'm now going to just press times 3, answer times 3, 4.226. So 4.23 times 10 to the 24 entities of Cl minus. All right? Okay. So sometimes when we want to find out individual parts or pieces of a compound, we have to multiply it by a factor. Let's do one more of these. All right. Find the number of atoms in 155 moles of oxygen gas. Okay. So again, atoms. Atoms are entities. Atoms are entities. Entities, moles, Avogadro's number. Again, I want the entity. N is equal to moles times Avogadro's number. 155 moles times 6.02 times 10 to the 23. (155) times 6.02 exp 23 equals 9.33, 3 significant digits, 3 significant digits, times 10 to the 25. 9.33 times 10 to the 25. Entities of oxygen gas. Oxygen gas is O2. This question wants us to find the number of atoms, not the number of molecules. So I'm going to have to multiply this number by 2, because there's 2 atoms in each. So this is the way I like to set it up. 9.33 times 10 to the 25 entities of O2. And now my little factor. It turns out there are 2 atoms in each single O2. All right. Where am I getting this number? The 2 in the formula becomes the 2 that we multiply it by. My calculator already has the number in there. I just need to multiply it by 2, and I have the number of oxygen atoms. Okay. That equals 1.866, 1.87 times 10 to the 26 entities of just O, oxygen atoms. All right. We've learned 2 things here in this lesson. We've learned how to use the triangle to calculate entities from moles using Avogadro's number. We've also learned how to take a chemical formula and turn it into a factor that can determine how many atoms or ions are inside of a compound. All right? And that allows us then to count all kinds of different things. Okay. At this point, there is homework out of the textbook and on that sheet that we started the other day that had the formula math, and you can now do the section called the mold. Like the last one, the answers will be in this PowerPoint. Okay? All right? All right. That's the end of the lesson. Again, if you are having difficulty getting your calculator to work right for you, please ask. All right? And I will come around and give you calculator training. Not during a test, but in class.